Welcome to another episode of Rocklaz Radio. This is your host Tanmay Shah, and today we are joined by a nuclear physicist, Ms. Sakshi Kakkar, and we are going to talk about many interesting things from quantum physics to quantum mechanics and how that's related to Shiv Tattva and spirituality and blend of spirituality and science and much more. Not just the theoretical side, but even the experimental side and what's going on in the world in terms of physics from small to small to large to large. I hope you enjoy the episode till the end and make sure to subscribe to the channel so we can keep bringing such amazing episodes to you and that you don't miss out. Cheers. So, welcome to the show. Could you please introduce yourself?
Thank you, Tanmay, for having me on this show. Introduction, sure. So, I am doing my PhD in experimental and nuclear physics from Triumph in Canada, Triumph is Canada's particle accelerator center in Vancouver, the beautiful west coast of Canada. So, and I think the only place or one of the very few places in Canada that doesn't go as cold as minus 20, minus 30 in winters. So it's a relatively very pleasant place to, live. So I have almost completed 6.5 years into my degree, and I am now writing my thesis, and hopefully I will graduate by the end of this year. So, yeah.
What is your field of study?
Field of study is experimental nuclear physics. So, if I were to tell you in layman terms, I would say, can I say that? Layman terms? People will be like, what the heck? Okay, so...
Or are you worried about the feminist? Why man? Why layman?
No, more about like that, okay, तुम बहुत पागल समझते हो कि अपनी ऑडियंस को why layman terms आई बड़ी हीरो
No, you're here to simplify things.
Yeah.
We don't know about jargons
Yes.
from the science journals. So that's why we want to connect
Yes.
to what's going on.
Okay, perfect then. So, yeah, so I work on something which is called penning traps. So what it does is, as the name suggests, trap. So the nuclear particles that are created via a nuclear reaction. So we trap those ions in a very tiny volume, and there we manipulate the motion of that ion which is trapped, and through that we measure the mass of even a single ion to the precision of, I would say, 10 to the power minus 8 minus 9. So in very simple terms, sometimes, when I am also a tour guide at Triumph, so I give public tours at the lab. So, there are all sorts of people who come in, who join for the tours. The youngest has been a 5-year-old girl. I think the questions she had for me, oh my gosh. I was like, if I can answer those questions, I have graduated successfully. So, so sometimes I like to tell them that it is just a weighing scale. The machine that I work with, the penning trap system, it's a very complicated, a beast sort of a system. But in simple terms, it's a weighing machine which is so precise and accurate that it can measure the mass of a single ion to that precision.
What is an ion? How is it different from electrons and protons?
Okay, so a nucleus, so say an atom, it has a nucleus. Nucleus is the core of an atom because 99.9% of its mass also comes from a nucleus, because a nucleus has protons and neutrons. And then there are electrons that are circling around the nucleus. So if you take out, so now this is a neutral system because protons are positively charged and electrons are negatively charged. and the number of protons is equal to number of electrons. So positive cancels the negative, so it's a neutral atom. Now if you keep taking out electrons out of that neutral system, you will be left with more positively charged system, right? So say if I take out one electron, then that neutral thing, the atom, will be 1 plus 1 positive charge, which is what we call as an ion. So it depends on which element it is, or how many electrons does it have, and how many electrons you can take out of that neutral atom, and depending on that you can increase the charge state of the ion.
So ions are basically positively charged particles in the nucleus.
Yes, exactly. Positive, like it's a nuclear, it's an atom, but taking out electrons it becomes positive.
It's a positive atom.
It's a positive. You can say that. It's a positive atom.
Okay.
Yes.
We cannot see the atoms. But how do we know so much about them? How can you even measure them if you cannot see them, even with all the equipments we have?
That's a good question. So I would say this whole story dates back to many, many years ago, when I think Rutherford started doing an experiment, and he said that was like an aha moment for him, that I think he was trying to, he was using a gold foil for some experiment, and through that he understood that, most of the space, like in an atom, because the particles that he was reflecting was just getting scattered or moving through the atom, which made him realize that most of the space in an atom is empty. So what is going on? So I think through that, then it was an evolution when they went to, with further research, a plum model came into being. Then there was something which was like a solar system where, the physicists thought that nucleus is like the sun, and then electrons are, revolving around it like planets. So I would say this has been like an evolution of, the research, and to know more about atom and the nucleus itself. So slowly and steadily, once they learned more about it, then more experimental setups were created, or we also, then I think the world of cyclotrons and particle accelerators was introduced, because if you want to know more about a nucleus, the energy has to be very high, because the particles inside, they're like bound in a very, very tightly. So if you want to bombard and go into what is happening in the world of a nucleus, so the energy has to be very high, and that is what paved way to the world of particle accelerators, which now we have so many in the world. CERN being the first one, or the biggest particle accelerator physics lab in the world, and then Triumph is a similar kind in Canada.
So how do you select like one atom that can be fired and then crashed into another atom?
So in the particle accelerators, it's not just one that is firing into one. It's a continuous beam. So like I can tell you about how we do it at Triumph also. So it's a continuous beam of protons. So protons are what? So say you have a hydrogen atom. A hydrogen atom has just one proton and an electron. So if I take out the electron from hydrogen, it will be left with just one proton, right? So this is how we create we create this positively charged beam, which is the proton beam, and then it's a continuous beam which enters into the cyclotron, which is what we are using at Triumph. And I should really tell you about this, that we have the world's largest cyclotron at Triumph. So it's a different type than what is there in at CERN.
What is a cyclotron?
Cyclotron. So it's a type of a particle accelerator. And how it does is that, say at the center, so it uses a combination of electric and magnetic fields. So you'll see like big giant um magnets that are, placed together. So it's in a form of a wheel which is segmented into six sections. So, and it's about 18 meters in diameter, and very, very heavy also. So that produces a very strong magnetic field, and then we provide a radio frequency electric field to it. So through that, what happens is that when you inject proton beam in the center of the cyclotron, because of this electric and magnetic field, it increases the speed of this proton beam to about 75% speed of light. And to give you a context about it, if with that speed the particles were to go to moon and come back to earth, it would just take them 4 seconds.
Wow.
So yeah, so that is what a cyclotron does. It really speeds up the particles, because again you want them to be really high energy particles, because now when they exit the cyclotron with such high speed, they will bombard onto a nuclear target. So there is where all the nuclear reactions take place. So different types again: fission reaction, spallation, fragmentation, different types of nuclear reactions take place. And then there are all sorts of you know amazing elements that are there in the periodic table. They
Hmm.
are created. So not only, so I'll take you back to the high school chemistry for a minute. So in the periodic table of elements, what we see is about 100 elements. So those are mostly the stable ones. So like they're not radioactive. But in such particle accelerator facilities, we are able to create the radioactive versions of those elements as well, which is called isotopes. So that is what we are interested.
Radioactive versions of even the regular.
Yeah, so say for example, potassium, right? So there is a stable potassium which we have studied in high school physics or chemistry. It is potassium 39. But that is not the only one that exists. So it has its radioactive versions, the unstable versions of it. And how I am saying unstable versions? So in the stable ones, there is a certain proton to neutron ratio. That is its natural existence. Okay. So if you take out some protons from the natural system, or take out some neutrons from the natural system, or say add some more neutrons into the natural system, so you can produce the different, which are not natural states, right? You can produce a variety of isotopes, or the radioactive versions of potassium, and so is like for other elements as
Hmm.
well. So it's about, in now I think about 3,000 of such radioisotopes exist, and there are more coming into the picture.
When you say radioactive element,
Hmm.
what it is? What is it that it radiates?
So radioactive, in simple terms, it means that it is in an energetic state, that it is not in its stable configuration. So now, if it is in its energetic form, it wants to get rid of that extra energy, or the excited state. Okay. Now there are different types of radioactive reactions or decays. We say alpha decay, or beta decay, or gamma decay. So these are, for example, beta decay. What it does is that it will release electron, and there are some fundamental particles which are called neutrinos, and then some energy. So that is a beta decay. Alpha decay is that there will be a helium 2 4 structure, what we say, that comes out. That is the alpha particle. So depending upon, there are many
So basically, it is emitting its own atom, like different parts of the atom. It is wanting to kick them out, or bring them in.
yeah, different fundamental particles, we can say. And
Yeah.
there is like reactions taking place inside a nucleus, so it's not something, that okay, it's constant, that yeah, proton or neutron, and then it can just kick one neutron or accept one neutron. Even the protons can get converted into neutrons and vice versa.
Okay.
So, because protons and neutrons are also further made up of fundamental particles which are called quarks. So, these quarks also, they can transform from one type into the other, which will change proton into a neutron.
In an unpredictable manner, or is it predictable how it changes?
Depends. Like it's not. So yeah, you have to be in a certain condition. Certain reactions take place, and then it also depends on the configuration of the atom itself, the nucleus itself. And we know to much extent that, okay, we can say very precisely that this is what the reaction will take place for most of the um, elements that we
Hmm.
have studied very well. But when we go beyond, a certain territory which we are still exploring, so it's kind of like, okay, a mix of both what theoretical
Mm-hmm.
physics says and then what the experiment does.
What is your role at the particle accelerator?
My role,
Particle accelerator is the right term?
yeah,
Okay.
exactly. So I would say that there are different teams who handle different things, because as I told you that this is like a big beast that we take care of at the it's a national facility where all the many international projects in collaboration, they are taking place. So there is a dedicated team of accelerator physicists who take care of the cyclotron itself. And my role majorly is as an experimentalist. So once, as I said, when the nuclear reactions take place and all these new radioisotopes are produced, then I am interested in some particular isotopes that I want to measure with my system, with the penning trap system. So my major role is to do the upgrades of that system, to take care of the system that it is ready for. And like even the radioactive beam, it is so hard to get for, like, say, a certain experimental group to get radioactive beam. It only happens, say, once or twice in a year, and that too also for like probably 3 to 4 days at a max, because it's such a fight for, there are so many experimental projects, the setup.
So is it because it's energy expensive, or is it because there's so much demand for that beam?
There's a lot of demand for that beam, because at such facilities, there
No,
is
but then
not
why
only,
just why just 2 times a year?
yeah, because there are, I would say, more than 30 groups fighting for the beam time to get that radioactive ion beam to do their experiments, and each one has their own science objective. So there is not only physics side of things, there is also the medical isotope production side of things that are happening at that facility. Then there are some core biology or chemistry research studies that also take place. So all of these different groups, they have their experimental setup at Triumph. So each one is, they have their demand. So I would say this the cyclotron, it runs for about 8 to 9 months in a year, and it's like going round the clock, so there is no stopping in between. Then it just stops for 3 to 4 months for a maintenance, maintenance period where no experiments can take place, but then it just runs back to back. Yeah, it's crazy.
So it's good that you yourself don't have to come up with new hypotheses. There are different teams who have their own hypotheses and agendas to find out from the accelerator.
So they have their own things, so the accelerator people are working on how to maintain that or do the upgrades with the cyclotron. Then there is a dedicated team that only works on the nuclear targets. So that, okay, which target can be more efficient, what temperature or pressure it should be at, so what are the certain isotopes that can be generated out of a particular target and how to get that into making. So they whole dedicatedly, like, they just work on that.
Hmm.
Then when it comes to experimentalists, we like, so say, this radioactive experiment takes only twice in a year, once or twice, but it's not that, the rest of the time we are just crazy working to upgrade our systems. Like, the recent upgrade that I did, as that was a heavy part of my PhD technical work, was to upgrade that system from room temperature to cryogenic. So right now,
What is cryogenic?
cryogenic is temperatures, very cold temperature, like below 0 degrees Celsius. So right now, the system that I have upgraded it to, it is a certain part of the system is operating at minus 250 degrees Celsius.
Wow.
So that was something, like, it was a major upgrade that we did to the system, and that has improved the precision to which we can do those mass measurements and accuracy, because that will further pave the way, for us to do even do experiments to go beyond the known physics right now.
Hmm.
So in short, I would say that the application of our work goes into three major categories. One is nuclear structure, to know more about the nucleus of an atom. Then second is nuclear astrophysics, which, in your introduction you said that we go from the smallest to the biggest. That is exactly what nuclear astrophysics does. So, when we talk about galaxies and all the world beyond, which we cannot even see or fathom, with our mind, it is actually connected to the smallest of an atom, you know. So when we can relate those studies, that is what nuclear astrophysics does. And then the third aspect, what we call, is fundamental symmetries, or going beyond standard models. So standard model, I would say, is like Bible of physics. We know what is there, that all the particles that exist, all the governing forces that exist, and going beyond that. So what is new? So, yeah.
Okay. Let's let's talk about quantum physics and quantum mechanics and about the presentation you made and
Hmm.
Shiv Tattva. So can you take us from the basics to your conclusions about those things?
Sure. Um, so I'm not directly working on any quantum physics project. I'm just giving a heads up. But I mean, as a part of my physics research, I have studied a lot of quantum physics, and then with my own curiosity, I have explored that regime. Yeah. So I would.
Basically, what is
Yeah, yeah,
quantum
yeah.
physics?
Sure. So let's start from classical physics. And the evolution I will talk about, which I think would be interesting to see that how things have evolved in that dimension. So classical physics talks about all the world that we see and we can touch, and we can determine what. So say, for example, you have a ball in your hand. If it's certain, the way that it's going to move, so you can predict that, okay, what will be its speed at a certain distance, or if it has a particular mass, things like that. So through which we can say that there were Newton's laws that governs this whole world of classical mechanics, and we can predict many things about the world that we see. Okay, so once you move from classical physics to I think I should expand on this. So what happened is that maybe you've heard of a double slit experiment that happened. So what very interesting thing happened there. So what physicists did was they were doing some experiment again, and most of the times it's so funny that the experimentalists are working on something, but then in that process, they come across that, okay, I was trying to find XYZ, but hey, what is this happening that I am seeing ABCD? you know so they change their attention to ABCD, and then that is like, wow, something new just pops up. It was as if like, the nature is just waiting to reveal itself somehow. And I really like when Gurudev also says, that all the research or new things or new ideas, they come when you are relaxed. And that is what really happens, when you're really focusing on something, and then some other research just pops up. So
So the split experiment,
yep.
a beam of electrons was fired on a, I don't know, a sheet. I saw the diagrams through a small slit in a paper. And usually light would go only in two places, but this was going in multiple places. Can you explain that?
Exactly.
What the slit experiment was?
Yeah, so that is exactly what happened. So when that electron beam was being passed through only one slit, so then they would on the where the beam was on the detector, they would see that, okay, the beam getting projected and it came into like a slit form itself. So far so good. Now they introduced another slit. So now that electron beam was passing through two slits. So now what one would have expected is that you would see that two slit projection on the detector, right? Like two slits, just you just see them as a pattern. But what happened is, what the physicists saw was a pattern, like so many different, like a pattern of they call it interference pattern in physics. So that there were strips of like dark and white light, if I can say that way. So that was the pattern that was observed, and which was very strange, that okay, this is not just particles projecting onto the detector. There is some pattern which is being formed, and it can only form if these particles are behaving as waves. So this was like a big, a new thing that revolutionized the entire physics. That what we think or call as a particle, it is also behaving as a wave.
Wow.
Yeah, because otherwise that interference pattern is not possible. And another very interesting thing, what they did was, now they were like really keen on observing that, okay, they said that, okay, we are going to send only one electron particle through these two slits, and we are going to observe that through which slit is it going to pass. So now you see, when you have that keen observation, what happened when they were trying to observe? That particle just went on through the slit, went onto the detector, and it projected itself like just a dot, a particle again.
Wow.
It did not behave as a wave anymore. So that brings me to a very critical point: observation. Whenever you introduce observer into that whole picture, the result changes. it's very, I know it's a little weird for the rational mind to think about, but that is what is actually happening in quantum physics also. Maybe you've heard of the Schrödinger's cat, that if there is a cat in a box, it is dead and alive at the same time. So people are like, what? What are you trying to say? It can either be dead or alive. But what determines that state is your observation.
How? So for this experiment again, if we break it down,
Yeah.
we know it's alive
Mm.
because we know how long a cat lives and how when it has last eaten, and if you just open the box, you can tell it's alive.
Mm. I
So how
mean,
is it dead?
so now, it's not that now you're going to put the cat in the box for like 100 days and then say that maybe it could be dead or alive. So this was like, okay, I'll take a step back and tell you a bit about wave function. I think
Hmm.
that will make the picture a little clearer. So, and then we will go back to our evolution of
Cats.
cats, yes,
Kidding, huh?
and then quantum physics, and to how even quantum mechanics evolved into what we now call quantum field theory, which is mind blowing. And it's such a beautiful theory. I think this is the most appropriate theory which we can also relate to consciousness, and how the what we call particles, or how they are just excitations in the fields which exist everywhere, everywhere, and it is beyond time and space. Okay, we'll get back to that. So wave function. So what quantum physics says is it says everything in terms of wave functions. So what that means is that let me give you an example again. We talked about electron, right? So electrons are revolving around nucleus. So now electron is not just a tiny dot or a particle which is just going like wow 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 around the nucleus. It's not like that. That is how we try to picture, or in
See it in the diagrams.
see it in the diagrams, or in early stages of when you start learning about physics. That is how things are introduced to keep it a little simple. But actually what happens is that if this is a nucleus, the electron can be anywhere around it. And how the wave function defines it is the probability that the electron can be here or here or here or here or here or here at a particular time. So it tells you about the probability that, okay, it can be here, but you don't know where it is. And the state will change when you try to observe it. That is only when you can, exactly say that, okay, it was here, but that will be only at that particular space and time of observation. So, having said that, how you can visualize rather an electron is, say it's like a beehive, okay? So it's, moving like many, many honeybees are together. It's a beehive. And they are just, how you see them sometimes, like it's a pattern that you see, right? They're spread across in a certain space. They're spread across. You know that there are many, many beehives, many, many bees in there, but it's very hard for you to tell that, okay, this bee is at this particular position at this point, right? So this is how I think is closest to how I can
Hmm.
define.
That's a good explanation. I
Yeah.
was thinking more in terms of planets around the sun, but we follow a
Hmm.
particular orbit.
Hmm.
What you're saying is there's no orbit as such. They go anyways around it.
Yeah, so there is not like a fixed thing. Sorry. So there is not like a fixed thing. But at the same time, where this, the concept of quantum also came about. They were trying to understand that what is happening, if it is not a fixed thing. When that electron is circulating the nucleus, it has a fixed amount of energy. That is a quanta of energy. That is where that term quantum comes from. So this is what led to when we were trying to understand the connection or go from classical to quantum physics. So this was a big subject of research on how, because for example, if you have just a fixed if an electron has some energy, then it is always radiating its energy in the form of electromagnetic radiations. At some point it should just spiral down and
Stop.
bombard
Hmm.
onto the target, onto the nucleus, right, and just crash into it, but that does not happen. So that is what led to, again, this understanding that an electron has a particular quanta of energy, and to go from one energy level to the other, it has to absorb energy, which can come from many different ways. And similarly, if it has to eject out some energy, that will be also a fixed amount, a quanta of energy that it can release and go down to a lower level. So this is from where all this um, world of quantum physics started, with the quantized energy.
Energy of a particle. And it stays constant, it doesn't go down. Or we don't know about it.
If it is in a particular energy level, I would say then it stays constant. But yeah, if it can absorb more energy or let go through some reactions, that's a
Hmm.
possibility.
Okay, so the cat in a box.
Cat in a box. Okay. So now, wave function again. As I told you, that what wave function tells is about probability, that okay, this could happen, or the electron could be at this position at this time. So there can be hundreds of, or maybe even more, possibilities that it could be here at this time. Okay, so that is a probability. So how we define, or in more than the wave function, what the term that we use in quantum physics is probability only, which is in mathematical terms. If we represent probability as psi, so we take the modulus and square of that wave function and define probability, which we say that okay, I can give an idea that in this particular volume or region, the electron will be there. And if I sum total the probability of where it could be in this region, that should be equal to 1, right? Because the electron is there for sure, but it's just that I don't know where exactly it is. But if I sum total the probability, that should come out to be 1, because it exists for sure. So this is the thing. So Schrödinger is the one who had made way for quantum physics and laid the foundation of it. So he was trying to explain this concept of wave function and probabilities with the help of this analogy, cat. So that is where from this got very famous, Schrodinger's cat. So what he said was that if you put a cat in a box, now you know that the cat is there for sure, right? So the sum of the probability, or the probability of it being there, is 1
One.
for sure, right? But now it's in a box. Now anything could happen to a cat at any time. Now we are not going into that, that for 100 days it did not eat,
Ah.
then it will be dead for sure. But you just pack the cat and it has enough oxygen, or it's well fed, whatever. Now, but anything could happen to the cat at any point, so you don't know to like precisely that if it is alive or dead inside a box, right? So there's a probability. You can say there's a 50-50% chance, right? So that is how he was trying to explain this, that the wave function and then probability will be zero point 0.5 for it to be alive, 0.5 for it to be dead, and if you add both, it will be 1, which means it is there for sure.
Hmm.
So he was just trying to explain this concept.
Okay.
Yeah.
Then what? So what is physics and mechanics? Quantum physics and mechanics.
So now that when we learned a lot about quantum physics, which we said, okay, this is quantum mechanics in the sense that if you have a certain idea about wave functions and probabilities, you can tell to a greater extent about the position of the subatomic particles, their momentum, that how much, what their speed velocity will be at a certain time. So this is what mechanics is, like uh, Newton's laws. They tell us about position and momentum of particles at a certain time in the classical world, which is the classical mechanics. So similarly, now with all these things, and then again, there is something called Heisenberg uncertainty principle, which also revolutionized the world of quantum physics, which said that at one time, to the utmost precision, you cannot tell about a particle's um, position and
Position and
momentum
momentum.
at the same time. So with all this evolution, we came to a point which we started calling quantum mechanics, that you can tell about what's going on. But there was one thing that was lacking in this study, which was uh, relativity. So now, in parallelly, during that time, Einstein was working on theory of relativity. Where he introduced about speed of light, and nothing can go, nothing, no particle or anything can go faster than speed of light. And then he introduced about how this is all relative, depending on where your reference point is, even this planet, that planet, whatever. So quantum mechanics was lacking relativity into its study. So all was good until relativity was introduced, because then quantum mechanics could not give any answers. So that was a time when there was a need of, of a bigger picture to come into play, which is now what we called quantum field theory. This is so interesting. I just love this theory. So it's so beautifully concocted. So what it says is, and it also includes relativity into the picture. So what this theory says is, any fundamental particle that exists, be it electrons, protons, quarks that make protons, neutrons, or any sort of fundamental particle, they all exist in field forms. Okay? Imagine, like, for every sort of a field, there is, for every type of particle, there is a field.
What do you mean by field here?
So, field is that it,
Like a plane membrane.
a membrane, we can say, okay, and it extends to the entire space and time. Time is a very relative term. Let's just use space for now. So, and these fields, for every particle, they exist everywhere at any point of time. Okay, even inside our bodies, all the time. So say you want, an electron, it has the possibility to pop up, or come out as in terms of a particle anywhere in the space at any time. Okay, so now what is happening is, it says that, okay, everything in its initial stage just exists in the field form, right? Now, it introduces vacuum also. So vacuum, I gave this analogy in the presentation also that I presented at the satsang Art of Living, right the day next after Shivratri. So vacuum. We have a vacuum cleaner at home, right? So we understand it like vacuum word means that there should be nothing. It should be completely empty. Now, even if you use some, turbo pumps, how we use at particle accelerator facilities also to create a very good vacuum, so from our end, we are just trying to remove everything that there is. But physicists say that this vacuum is not empty, it's very dynamic. It has quantum fluctuations or this quantum field all the time. So now what happens, coming back to the fields again, all the particles exist in their field form. If, at whatever point when they have an excitation in that field at a particular space and time, they have some energy which they can take from the vacuum field, or there is something again called um, boson field, which I think I will come back to it later. Maybe you might be interested in Higgs boson and the God particle, So how all that came into the picture. So let me make that big story a little short and simpler. So we have these fields, and then, at a certain space and time, somehow this field, it got excited at a particular space and time. That excitation or the fluctuation in the field is what we call a particle. So particle is not in its like a rigid or something that exists forever sort of a form. So this is what is happening and what quantum field theory suggests. So now,
Just to recap, I'm imagining a field like a book or a paper like that. The field itself is vibrating, you're saying. And on top of that, the atoms are moving around.
not on
Not
top.
inside it.
So there's a stretch like a membrane. For example, you just imagine that there is a bed sheet. Okay, you've just stretched it really nicely, and there is a that's its field. Okay, now somehow, now say for example, you just drop a tiny little ball into it on top of it. You will see that there is it's not a stretched membrane anymore. There's a little bump into it, and now that ball is also, that is why, circulating. It has its own pattern. That's how. Now,
So basically, it's like the trampoline that they use for explaining the gravitational waves and the Einstein's theories about
exactly,
how
it's
gravity works. Yeah.
everything is a field, like how gravitational field is electricity. We know a lot about electricity and magnetism now, right? Electric fields and magnetic fields. So similarly, the particles also, what we call particles, they all have their, they exist in field forms. Now what we call particle is just an excitation in that field at a particular space and time, where you can just say that there is a tiny blip in that stretched membrane.
Oh.
So that tiny blip in that stretched membrane is what a particle is.
So basically, you're saying it's not like a marble or a ball roaming on the sheet, but the sheet itself has a bump in it which is roaming around.
Exactly.
Oh, wow.
Yep. That is what a particle is. The excitation in the quantum field is what a particle is.
Wow.
It does not have an existence or like a solid form in its own.
But then you're also saying that that bump in the sheet can be thrown out to another sheet
Exactly. That is
by
true.
firing at it.
Yeah, exactly. You know what? So energy is conserved, right? So there is, you cannot create or destroy energy, but one form of energy can be, and this comes from Einstein's mass energy equivalence also, that mass and energy are equivalent, right? So energy can produce masses, or even what is happening, even we talked about a radioactive decay, right? That one, the proton will decay into become an electron or a neutrino. So what is exactly happening? So there are fields, for each of these particles. Now that energy blip from one field is being transferred into the other. So say that energy from the proton beam is now transferred into the electron field and the neutrino field, and that is where now we are saying that the energy, the blip, will now be in the electron field
Hmm.
and the neutrino field, and the one in the proton field will just calm down because it has just transferred
Hmm.
its energy. So that is what is exactly happening. It's the fields where everything is happening. It's not like a rigid particle in its existence.
Wow. So that was proved by the split experiment.
No, no, not with the split experiment. This was with the split experiment. Told people or introduced that the particles are not only particles. They are in the waveform as
Hmm.
well. But then there was all these combination of studies and research with quantum mechanics, relativity, and all that, that led to the evolution of quantum field theory.
So it's not a one person thing. It's like a lot
No.
of people working on this.
Oh, many, many years and lot of people working together. So you know how this relates so beautifully to the consciousness.
How?
Wow. So, okay, now we will flip to the side of spirituality and how this is all connected. So, I would say that this physical form that we have. So, how I like to see or think about it is when we say Shiva Tattva, which is again this big expanse of consciousness that goes beyond space and time. So this is one stretch of it. The consciousness is one big stretch of field. And then suddenly, one fine day, a blip in it named Sakshi comes into being, right? So I was born a few years ago, whatever, and then there is one ultimate truth that I am going to die, right? I don't know where I came from. I do not know where I will go back, right? But this ultimate field, this consciousness or Shiva Tattva, what spirituality talks about, is what I like to really make that analogous to quantum field. That we also coming into being is just like an excitation in the field which remains there for certain years, whatever our lifetime is, and then we just go back into it. Because I think as a practitioner of meditation, and Gurudev has blessed us with infinity, as I would, if I may say, that this physical form is not what the reality is. And when you go deep into meditation, or into that state of samadhi, which is like you are aware but you don't know what's going around or who you are, but there is just a very gentle or a very delicate presence that you feel, right? at that time, like, you are beyond that field of thoughts and feelings and emotions. You're just in that sense of witness sort of a field, which is what that alive consciousness is. And this, I am not the only one who is saying this now. So many quantum physicists in the latest research, there is a very there's a scientist who is also an engineer. He's a physicist. His name is Federico, if I am not mistaking. Yeah, I think so. I don't remember. It's not on the top of my head his last
It's
name
okay.
right
It's
now.
okay. What did he say?
So he has been studying physics and engineering for such a long time, and he recently said about this, that this, the intelligence that pervades the universe is everywhere, and our mind is like a receptor, a frequency receptor, which is so true. Because how, like, when you are in that state of calm, you're meditating and you have a certain positive energy, how even the world of reality, what you see in this physical form, that starts to change, right? So again, I think there is a field of this wave function that exists all the time, which has the field of possibilities all the time and everywhere. It's just that how in tune, or in what you are in tune with, that that your brain or your mind becomes the frequency receptor of, and the reality of your being becomes one with that, or that is what you start seeing in the physical form as
Hmm.
well.
So you are comparing the experience of the field from a particle point of view, and then we are observing, or we are seeing that it's the same when we meditate. We are able to observe that field in meditation and be one
Totally,
with it.
totally. Because this physical form is not what that the truth is. No, it's really beyond, and consciousness, which is this big field, and which is, if I may use the word, the intelligence which is governing everything that exists in the universe. And again, this is not the only universe, or the solar system that there is like infinity. There are so many universes, and then they have their own galaxies, their solar systems, and whatnot. But this intelligence, which exists in a tiny thing, which could be an atom, or a tiny thing like an ant, which we can see, human eyes can see, or something as big as, I don't know, mountains or stars or galaxies. There is this one intelligence, one consciousness, which holds everything.
Absolute intelligence, AI.
Absolute intelligence, AI. Exactly. And then we just, because even how you see that the what some nowadays people talk about manifestation a lot. I would say that there is a lot, it sounds like a very cool word, and sometimes people also get very distracted by how they can only just manifest things. It's not only about that, but you have to really take a step back and, look at the bigger picture, that what is really happening, how the reality in the physical form comes into being. So there is a lot that you need to understand on the bigger picture, which is at the consciousness level, which, how Gurudev says that when you go into that silent space which is inside of you, then only you can get in touch with who really you are.
Hmm. We have two ways of getting the information. One is from the rishis who have been meditating and figured these things out, and one is the scientists and the physicists like yourself who are observing and actually discovering these things. How do you bridge these two things?
Very good point. You know, a few years ago, I was very much like into my left brain, you know, that I used to think that science and spirituality are two extremely different things because science just, shows me, gives me a proof whenever I want. Might take a few years, because sometimes when you want to experiment things, but at least there is a direct experience that I can get through it. But over the years, and also I would say meditation has played a very big role in that, and of course, the meditation and Sudarshan Kriya that Gurudev has taught us or gifted humanity with it. So I started exploring that aspect as well. And as you said rightly, that there is so much that the rishis have talked about. So it was amazing to me that when I was exploring some of the spiritual content, the Vedas or some spiritual books, they talked about black holes, they talked about atoms, they talked about gravity and the forces that exist in the nature so beautifully and precisely, which was quite an eye opener for me.
For example,
Like,
how did you know that this they are talking about black holes? Because
oh,
all the text is in Sanskrit.
yeah, but they were, s- it was quite clear that how they would say that far somewhere or like beyond earth or something like that exists where gravity is the force which is playing its major role and nothing can go beyond it. So they would use like very clear terms like that which directly relates to that what they're talking about. So another example that comes to my mind is splitting of white light into seven colors. Now, I don't exactly remember the phrase, what I read, but they said this that the shwet, the white, they were not using the term light also there, but they talked about this white thing that splits into seven. So, when you pay a little deeper attention to it, and then when you read the content and you try to connect the dots, you can very clearly see that, okay, what is this white thing that they were talking about that splits into seven? It's the seven colors which the white light it constitutes of those seven colors, right? So things like that. And it was so beautiful, like even yeah, they talk about, I cannot say directly about the weak and the strong forces that mostly govern the world of nuclear and particle physics, but and I am yet to read in depth about it, but they have mentions about certain other forces also that prevail in the universe.
So, is it possible that taking a reference of these texts, you direct your experiments in that angle or field? What is this they're talking about? Maybe I should check it out with an experiment.
That is hard to say because the world of physics right now, or especially the experiments, how they are proposed and everything, it involves a lot of thinking in a different direction or trajectory altogether. Involves a lot of politics, as so, is I think quite common in other aspects of our life as
No,
well.
why I'm asking is because there have been several occasions and reels where people say, okay, this was mentioned in Quran as well, it was mentioned
Hmm.
in Bible as well. But they only are able to correlate things that have already been discovered,
Hmm.
but not about what is yet to be discovered.
Hmm.
So it's basically, I think it's like poetry, which can be, there are some words
Hmm.
which you can imagine and give meaning to it and say, okay, this means this also.
Hmm.
This also means black hole, or this
Hmm.
also means that.
Hmm.
But they might have meant something else.
Yeah, that's a possibility. Yeah, I mean, so
Or
it's.
if they were indicating about black hole,
Hmm.
they might have said something else that we still haven't discovered.
Definitely. And I think that's a good point that you brought up right now. So, we think that our mind is what is like the most important thing in the universe, or nothing is beyond that. That is how majorly most of the scientists also think, and I was one of them, I would say, a few years ago, before I was introduced to spirituality. Because but now, and even the scientists, even, you look at how scientists like Einstein or Heisenberg, what they have really talked about, in some of their books, is that you can go up to a certain point with your mathematical calculations and physics and everything. But beyond that, there is some intelligence which is beyond the mathematical equations. And this is what Einstein also said, who, and we all know who Einstein was, like such a brilliant scientist and a mastermind, right? So, this mind is also, I would say, it's a part of the creation of the bigger picture of this universe. It's not the only or the best thing that has ever been, that has come into the picture. So there are limitations to what this mind can also perceive. Whereas when you go into that state of consciousness, which is the all knowing, which is the reality, and there it is beyond time and space, okay, it all exists. So I think, which is a direct link to what, how were the rishis able to tell us about so many things? There was no concept of time, there were no particle accelerators that time, nothing at all. But with that deep intuitive levels, which happened through their meditation and everything, they were able to connect themselves to the consciousness, and the things revealed to them, they were revealed to them through that intuitive abilities. So that is what, because how I like to see, or how I think about it, is the mind catches up with what is seen, or the experiment that has happened. Then you try to understand that, okay, this is what I observe, this is what my data is. Now I am going to do my data analysis, and I am going to come out with, okay, a conclusion, right? But this is very delicate, or like a very fine line into understanding this point. Whatever happens, it happens in its natural form, because what that is what it is. And then science or physics, it tries to catch up with that, you know in terms of, okay, we'll do an experiment, we will get some data out of it, we will do our data analysis, and then we will see what the results say. And then we will also match with, you know, say for example that what theoretical physicists say, they start with assumptions, right? They don't know they're doing research about some new physics. They don't know. They do start with some assumptions in the beginning, and then they go about, okay, doing their research. And then both experimental physicists and the theoretical physicists come together to compare their results and their research. And when that matches, then it comes out like, okay, we can say that we have something new, or or a theory can be developed around this point.
So you can call the rishis as theoretical physicists, and we are all catching up to their theories.
Yeah, that's one way of looking at it. I think that's a fairly good viewpoint. Because
They could be experimental also, right? Just by thoughts. I don't know. You tell me. Because they have come to conclusions without experiments. How is that?
yeah. So to me, it goes beyond both experiment and theory. It's a very different field of energy that we are talking about there. And another thing that, I think when I see all these intuition kids now who are doing the Art of Living intuition programs, how are they able to tell things blindfolded? And, that is, I think, a very big eye opener in itself for people who are yet to, um, believe or step into this realm of consciousness or spirituality. What answer would you give to your logical mind? How is this happening? You cannot give a logic, but it's happening. You blindfold their eyes and they're able to tell you whatever is in front or whatsoever. So many questions they are answering. So,
We
the.
had an episode on that, episode 101.
Hmm.
We had a teacher of the intuition kids. He also recorded the video of them
Hmm.
in person doing those things.
Wow.
I experimented it, trying those
Hmm.
things myself, and I was surprised to see.
Yeah. It is mind blowing. So I think that realm goes beyond the logical mind. I am really amazed I am saying this statement now because I used to live only in my left brain. Like, okay, if my eyes, if my logical brain does not see, a proof or things, oh, nothing exists. But it's good. You keep questioning. That the Gurudev also says, keep questioning until, keep doubting things
Mhm.
until you start finding some answers.
Yes, yes. By episode 102 is the intuition
Hmm.
episode. What is the God particle?
Hmm. God particle. You know how this name came? God particle? Because it sounds very counterintuitive to physicists. Because most of them are like, who is this God? And physics is physics. We don't introduce terms like God into physics. So it's a funny story. Excuse me. So, yeah, so you know what happened? There was a lot of research going around how the particles have masses, and in the world of subatomic physics, how are these so many particles come into being, they transform into one another, what is going on, and especially how do the some particles do not have masses, they are massless, some acquire mass, some are lighter, some are heavier, how are they acquiring mass also. So there was a lot of research was happening around this. um, so once there was a conference or a meeting of researchers, and they were like fed up of thinking about, okay, what is going on, and then suddenly out of that fed up thing, they said that, I don't know what goddamn this particle is. I have read this in an article, and I've also seen some videos about it. So I cannot confirm the like 100% if this is a true story, but I have really read about this. So I'm sharing it. So they were like, they were so fed up. God damn, what this particle is. So and then the research went further up to the point, I think in 2012, when this aha moment at CERN came about, when they said that they have discovered a particle called Higgs boson, which they started calling. So the theory or the research behind this particle is that it belongs to the family, to the boson family. It's a family of a type of subatomic particles, which can be, the theory has evolved from them then to now, but that time it was thought that the bosons are the ones that the boson field is the one that gives mass to the particles. So that time when they discovered this, they started calling it as God particle, which came from that, goddamn particle, what is happening? Who is giving this mass? So then they got that God term. They could not call it goddamn, so they just defined it as God particle.
Do you think God is like a filler term? Whatever things we cannot explain, we call it God. Neil deGrasse Tyson was telling on one of his podcasts this.
Yeah, I think that is true to a certain extent. That people, when they don't understand, which is, I think, also even to this, in this context also, Higgs boson context also, then because when they thought that, okay, if this is the thing or the particle which is giving mass to all the other particles, then this is indeed something like a very basic or fundamental or basic, so we can call it God, that from this everything has evolved.
Hmm.
So, but yeah, I think God, yeah, is people use it quite loosely also.
So this Higgs boson also have strings inside them or vibrating. What is a string theory? And
String
how is it
theory,
related to this particles and quantum physics?
I wouldn't say that it is like very directly related, and it is also quite redundant now.
Is it?
Quite a bit, because it's yeah, depends on like what type of what type of what section of theoretical physics research are you in.
So
But with
is it
this
like there are like bands, vibrating bands inside the electrons?
we
If you
can't call it
subdivide
bands,
uh,
but yeah, there is, I mean,
strings.
there is like vibrations, which is what they're calling it, strings, right? Which is, I mean, any fundamental particle, if you go further down to anything, protons, then further quarks or whatever, everything is a vibration. It is vibrating. So they were trying to explain some of the things based on this vibrations, and they started calling them strings, and string theory
Hmm.
evolved. But with this Higgs boson, so how it was, it is again like when I talked about quantum field theory, when I said that each particle has an underlying field. So this boson field also exists.
Hmm.
So each field, when it interacts with the boson field,
So is it like a different field?
it is a different
So
field.
you are saying there are many fields, there are many bed sheets,
Many bed sheets.
bed sheet on a bed sheet.
Yeah, each particle has its bed, has a bed sheet of its own. So yeah, when they interact with the boson field, that is also a theory,
Hmm.
that they acquire their mass through the with that interaction, and that is how then this was a good starting point to
Do you think
understand.
there can be a universe inside an atom?
A universe inside an atom.
Or
Totally.
whatever the smallest part is?
99% of an atom is empty. So an atom has a nucleus inside it, right? And this nucleus is a very tiny dot inside an atom. I could give you an analogy. So, say there is a football stadium, and in the center of that football stadium is a tiny pea, a green pea that is sitting. Or rather, I should say, maybe a combination of 3 or 4 football stadiums, not even one. So, that huge of a space. And then in the center of that space, you keep a tiny little green pea. That is how a nucleus inside of an atom is placed. So, it is so tiny. And 99.99999% of an atom is empty. It's totally empty.
But you just said that there's nothing empty. There is something even in the
So, in
vacuum.
that emptiness, maybe a universe exists because it's not empty.
Okay. Guruji was saying in one of the satsangs that if you're a if you have a physics background or you can understand this thing very well
Hmm. Understand about atom?
about consciousness, about God. He was giving some
Exactly.
explanations. Do you recall that?
I do, yeah. And that is what I think when he said that, I thought about that, what we talked about,
Huh.
no? The
That
consciousness,
everything is an
the
energy.
stretch. It is an energy indeed. Because this physical thing is just, again, an excitation, and how we talked about the consciousness, which is the quantum field. So it's the same thing. It's the two sides of the same coin. It's not different.
So you mentioned about Shiv Tattva.
Mhm.
It is again that same field that you're talking about.
Exactly. Because Shiv Tattva, whenever Gurudev talks about Shiv Tattva, he
Hmm.
says, no, that it's all pervading and nothing is out of Shiv Tattva.
Hmm.
Anything and everything that exists in the universe or beyond the universe is inside of Shiva Tattva,
Hmm.
which is this all pervading consciousness, which is beyond space and time. And time is something that it always just keeps coming up, time. So if you think about it, there is no physical significance to this term, right?
Hmm.
What is time? Is this anything that you can really comprehend, or how did it come into being? So say let's go, couple hundred years back, when the people did not even know about sunrise or sunset or anything, and they would see some patterns that, okay, at this time there is some ball, this fiery energy ball, the sun. It just comes, everything brightens up, we see the world around us, and then after certain whatever, it just goes away, and then it just comes back again and all that. So that is how, they just started with this concept of, okay, let's just start doing matching. And then they would see phases of moon, which would be like, okay, you see a big white ball, then you just see that it starts disappearing. Then there's a crescent moon, not even moon, they did not know, some ball. Then it just completely goes away, then it comes back. So why am I saying all this is because all these were the patterns what they were observing in nature, and then through that they started making some points of reference, right? That, okay, if this ball is the fiery ball is on the top,
So
that
basically,
means it's
time
a
is nothing but it's just a pattern that you can observe.
exactly, because this is how, like, slowly when things evolved, we got to know about, okay, this is sunrise, this is sunset. Then we started calling it one day. Then when we observed some more patterns, we said, okay, this is a month. Then we can just divide this into 12 months, because summer repeats itself in like 12 months, so maybe we can call this circle as a year, right? And then time, then you want to dissect your 24 hours into da da da, minutes, seconds, everything. It just all came into being. It's a concept, right? Otherwise, other than that, if you take a look at a bigger picture, what is time,
Hmm.
right? So Shiva Tattva, or the consciousness, or the quantum field, it just exists irrespective of our concept of space and time. It is, and that is what the existence is.
Hmm. What experiments can you do to discover more about the Shiv Tattva?
More experiments.
Basically, you said that there are different fields.
Hmm.
So there could be like a supreme field which is all these fields are based on. Could there be that? Or maybe the consciousness that we talk about
Hmm.
is a field, and with that consciousness we can manipulate the other fields.
You are actually talking about, what physics calls as, or is trying to propose as, a unified field theory. It is exactly doing the same, that, we have to eventually, we want to go towards coming out with a theory that knows it all. So, which will combine all these quantum field theory, then relativity, and this quantum field theory is also incomplete right now because it does not include gravity into the picture. So you have to still leave, few things
And
apart.
that's another field.
That's another field. Gravity is another field, and it has its own, the excitations or the particles, the gravitons, what we call, how they exchange, and then all this field comes into being. So that is exactly what physicists are trying to do, to get everything all together, make one big unified field theory, which will be able to
When
give
we talk about
answers.
gravity, it just basically refers to these huge objects like black holes and stars and thing. How does that gravity influence such a tiny object? I mean, I had heard that gravitational wave, even to very bit, you don't realize it, but your body also enlarges and becomes taller and smaller when the wave passes through you, just a bit.
Yeah,
So, does that affect the particles also in that way, or we are still discovering that?
we are still
Or does it lift the whole particle up and down? Or does it?
we are still trying to understand more about that how, because all these theories that we have as of now that explain about, the forces and the subatomic particles, and the how they govern the world of subatomic physics.
Hmm.
So gravity is excluded from that part as of now. But what you said, that, we have, there is a gap of it, the that just reminded me of a very interesting fact, that when you sit on a chair, okay, there are electrons in you, there are electrons in the chair, and there is, so those electrons and electrons, they repel each other, both are negatively charged, right? So we feel that, we're sitting in the chair and there is a direct contact, but there is, I think, a layer of gap which is about 10 to the power minus 8 centimeter or millimeter, which is, down to that level, because that is creating those repulsive fields between the electrons, and we are not really in direct contact. So,
Yeah, that's what I wanted to ask also. You said 99% of the atom is empty. So why can't I pass my hand through the mic if all these atoms and this atom is empty?
yeah, so that is, I think the answer to that is also again this the electric repulsion, the force that we feel from electrons. Because, when you're trying to say, you bring your hand closer to a solid object, you cannot pierce through it because there are electrons in that object also, and there are electrons in your hand as well. So they create a repulsion, a repulsive force which does not allow you to penetrate through. Like you have to go down to the scale of that energy because they're bound so tightly, right? You really have to have a very strong energy to pierce through.
Yeah, this reminds me of this movie Flash. It's a DC Comics ka movie.
Okay.
In that guy vibrates himself so fast that he can pass through walls
Ah.
just because of his speed and his vibration.
Maybe he's doing some, what is that called? Quantum, not entanglement, uh, quantum tunneling to
Probably.
just pass through it.
So if you shake an atom so fast, it can pass through other atoms.
That is some concept of quantum tunneling, which is also used in quantum, all these traps coming into the supercomputers and everything.
I'm just feeling so smart right now using the word quantum again and again.
Very good. I'm happy. Yeah.
What are some other fun facts?
Fun facts about.
Okay, let me ask another question.
Hmm.
What is your story to come to spirituality from science? You said you had a very logical mind.
Hmm.
How did that turn into spirituality?
Ah, interesting question. So, yeah, since childhood, I think I used to question things a lot in the sense, um, when I started studying about science and physics, and especially towards grade 10, 11, and yeah, so on so forth, I was introduced to this world of atomic physics, and where I think so. One of my professors, my school
You were in India
teachers,
or Canada?
I was in India. So I did my undergrad and masters also from India. Undergrad from Delhi University, and I did my masters from NIT. Then I moved to Canada for doing PhD. So my schooling happened in India itself. And in my so my physics teacher, his brother was a scientist, a particle physicist. So through my professor, my physics teacher, I learned about this particle physics, the world of particle physics, and it was so fascinating for me that like how can you explore something which you cannot even see? How you asked this question a little while ago, that like how can you just know so much? And I was like, this teacher is trying to tell me that the stars, which I cannot see, but they are huge, right? Like the galaxies and everything, they are connected to atoms, which again I cannot see, but they are so tiny that I cannot see them. How are these two connected? And then my teacher is saying that his brother is doing some research on this, which says that these two are connected. So that was very mind boggling for me. So I think that was something that I wanted to pursue. That okay, I could try physics. So I got into BSc Physics honors, and I did some voluntary projects during my undergrad also. So there was again a research professor who was a scientist at CERN lab, and he was doing some particle physics projects. So I started working with him. So there it just started. All of this started, and it was very interesting. So I just kept going. That okay, I could do masters and then maybe PhD and all that. But with the spirituality part, I belong to a religious family, and we would do our prayers. And my parents introduced me to Krishna and Radharani at a very young age. So we used to pray to them and go to temple and everything. But even when they used to do some prayers or whatever they used to do, or there used to be some talk about some, say, Bhagavad Gita or some other book. So I used to be very keen into what the spiritual masters had to say. And so many times it would happen that those questions or whatever they had said, they would just get stuck with me because I would not get answers. So I used to question all that a lot. And then I think it was something since my childhood that I was quite a deep thinker, and I was more into trying to understand what is this universe, what is going on, what is happening, rather than getting answers very easily, or just being like a gullible kid or like that. I was not that person. So maybe some deep impressions from past lifetimes or whatever. So then I was in that stage, grade 12, and transitioning into college, and preparing for entrance exams and all that. And that time there was, like, my family was also going through a very rough patch. Yeah, like, personally. So that was a very disturbing time for me. So I faced, sort of depression, and I was just going, I was a smart kid, doing well in academics and everything, and quite talented, an all-rounder sort of a person. But then suddenly, over a year or two, I was into, like, not even at zeroth level, like even below that. So my sister, she was, taking her MBA coaching, and there a team from Art of Living came to give an intro talk about happiness program. That time it was a Yes Plus program for youngsters. And then when she was noticing me for quite some time that I was going through such a rough patch, so she got that pamphlet from her coaching class, and she said that these guys today were talking about something around this topic, and how about you just go give this a try. And then I was like, sure. When you just don't have much to, like, much positivity in your life, then you're like, okay, maybe I could, life can only get better, or maybe it will still remain the same, but it is already at such a low point that it cannot
Cannot
go
go lower.
cannot go lower. So it took me quite energy and time to convince my parents and my family to participate in that program, because getting money from them, and then all that stuff. But somehow I landed up into that program. I did Yes Plus, which was for 6 days that day, and I don't know what happened. I was just so happy. Like, I really don't know what they did, that teacher or that program did to me. I did not have, like, any connection to Gurudev at that point. I did not even understand the concept of, okay, what is a guru? Why do I need a guru? There was definitely a beautiful picture of Gurudev in that hall where the program was happening. And my teacher was so amazing, and I think she did the groundwork for all of us. And I owe a big chunk of my gratitude to her, because she was so pure and sincere in what she was doing, that that made all of us instantly connected with her and to the program and the practices. So I just felt a very high degree of belongingness, to the point that I never wanted to go back home. at the end of the program, I was sobbing like anything that don't tell me this program is over. I don't want to go home. So I think that was the start. I kept then going further with it. I was very good I mean, good in the sense, come what may, I was like, I am going to do long suggestion Kriya and Kriya every single day. So this kept happening for, few years. um, then as in between I was going through my like a lot of changes, masters, and going from one city to the other, then all together to PhD. Then there was a certain patch in between when I just stopped doing Kriya at all. Like I was doing it so religiously for so many years that my friends, they used to call me, it's a funny word, but I think I can say that. They used to call, and they still call me Aula. Now, what that
Aula.
stands for is Art of Living Advertiser. It's so funny. Even in my in my hostel and everything, when I would do, they used to make fun of, like, okay, every morning this girl just sits and starts doing something bastrika and whatever. So I did advanced course, DSN, all that stuff, practiced it for quite a few years, and then suddenly it just got off the radar. You know that I stopped even doing Sudarshan Kriya completely. And that time I just did not know that how to find a group or whatnot. And then life took over, then so many transitions, health wise, family wise, a lot was happening, and then it was completely gone. Then I go back to Canada, then I go to Canada for PhD. And then I get in contact with the Art of Living group again, and within few months of, like, I when I just got to Canada, about in 2 to 3 months, Gurudev was coming to Canada, and all of us, as a team, we went we went there. And I have no idea what happened that day. It was like some program in a hall. We were sitting there, and Gurudev was there. And when I just saw him, and he was just, singing some bhajan or doing something, I was sobbing like anything. And I was, in my heart, there was just one prayer. I don't know where did it come from. Gurudev, you take me with you. I don't want to be here. I just don't want to be here. I am so sick of this. You just take me with you. I was just saying that, and everyone around me, like my friends and teammates, after a certain point, they got really worried because I would just not stop crying. I think I cried that day for more than 2 hours, or like sobbing, like continuously. I don't know what happened. So that was the time I would say that, there was like again a U-turn sort of a thing, that Gurudev just came and snatched me
Hmm.
back. So, yeah.
So what goes on in your mind? Physics people in science are very logical. They need a hypothesis. They need to test it out. But spirituality is a thing where you have to believe in things you cannot see or prove or see evidence for.
Yeah,
It's more like a faith or a belief on unknown. And
totally.
physics is completely that you only believe what is known, but you
Exactly.
try to figure out what is unknown. So, how do you match these two lines?
That's a great question, you know. So I think, for my personal journey also, the journey played a very big role. There was a big chunk, in my life where things were just going wrong. And this was like in Canada. Everything that could just fall apart was just falling apart. And then I was in that phase where, I was really wondering that if someone could just turn off my life's switch, I would be very happy to just, like, okay, let go of this life. And I think, even me being here in in Bangalore right now is such a miracle. Being in India, because recently, like a couple months ago, my mom was diagnosed with breast cancer. So that's what brought me to India. I wanted to be with her through her treatment and everything. So, and long story short, that is what brought me to India. And now I am here in near the ashram. These last couple months, that I have spent here, they have turned my life 180 degrees. And I would over and over, go back to what Gurudev says: you don't know who you are. You don't know who you are. When you keep up with your practices, that is what I did for the past couple months. You keep up doing your meditation, everything else comes to you. The faith also, initially you do need to have a certain degree of faith, but slowly, things just keep developing. And today, if someone asks me, how are you? I am like, I am a bomb of enthusiasm, of energy, and I owe that all to my master, to Gurudev. That's it. So, we have to, there has to be a balance. So, when you really hit that rock bottom, you start questioning about what life is, what is going on. So I always used to recall, that Gurudev says that there are only in two situations, or mostly in two situations, when people start thinking about who am I or what life is. One is either you're like really in a good space and you're sort of enlightened and you want to help the world, and then you have all of these questions, and then the second thing is you hit your rock bottom. So I think I belonged to that second category. When I
Hmm.
hit the rock bottom, I started questioning, this is not what life is all about. This should not be, at least. That, is it only about suffering? Is it only about, that even if Lord Buddha used to say, "Ye dukh," it is a dukh world of sadness or whatever. But this is all that I see or feel is not what is the truth. That is not what this world is. So I think through that, I started questioning and exploring. It's been I wouldn't say it's been an easy journey, very tough and challenging given all the other aspects of my life, personal, professional, everything. But I think it's the faith also that kept me going. And now, when I, look at the bigger picture as a whole and I connect the dots, I think I can see it more clearly with both these aspects, that science and spirituality, it is one.
Hmm.
And that is what Sanatan Dharam, our Vedas, and everything has ever since talked about. It's very scientific. It's very, very scientific. I recently came to know about, the 16 samskaras that happen in a human being's life from the time they are born, or even,
Conceived.
when they're conceived, to the point when they die, right? So everything, how even the conception at that time, how they used to, the husband and wife, they used to approach the pundits, and they would, depending on what certain qualities they would want in their child, they would do certain ceremonies or particular dates and time matching the astrological charts and whatnot. Slowly, and everything was so scientific. Certain samskara, which is, once the lady has conceived, she has to be in a certain environment, and which was again that, she should be in an environment which is very calm, is well taken care of, should read scriptures, chanting, because all this, the mantras, all these vibrations, what they are doing to your nervous system, all science, right? You sit in Rudra Puja, that happens here every Monday. You don't know. I don't know what the meaning of that chant is. But then the moment, like when you sit there, I don't know what it does to me, but it's like your mind is empty. So it's again, then there is so much of research on this, right? That how the vibrations, the sound vibrations, what it does to your nervous system, all very scientific. So everything that you will see, if you really dig deep into it, and all of this also I learned from one of my very dear art of living teacher himself, and who happens also to be an astrologer. And so everything is so scientific. So you cannot just say that, okay, you're just, everything in spirituality is just based on faith. No, it's science. It is core science.
Oh.
Yeah, one has to have, I would say, deep thinking and an open mind to, okay, you go with an open mind. Because in my lab also, like, I see that there are excellent scientists, but they're not open minded. The moment I talk about meditation to them, they're like, whoa, what? This is not our realm. I don't understand what meditation is. I cannot even sit for 1 second. And I just sometimes joke with them that you're having 20 cups of coffee a day. How can you sit still? So much caffeine in your body. But jokes apart, that's the thing. Like, the open mindedness has to be there to try to. And again, if you don't know something, does not mean does not exist, right? What I know is only a very tiny part of what this universe is, and that through what my logic today is only coming from whatever experiences I have had, whatever perceptions I have made of that. That's it. It's a very tiny dot in an ocean. So I cannot claim that, okay, something does not exist, because I don't know.
Hmm.
There has to be an open mindedness and a keenness to know
Hmm.
both the sides, and readiness to involve your time and energy to
Hmm.
to to deeply analyze it.
Hmm. I mean, the scientists could take it as a project to understand. Instead of being averse to it, just trying to understand what it is. You use your scientific logic,
Yeah.
try it, test it out, and see how it is working or how it is not working.
Exactly. That is the way to go. And Gurudev also says the same thing, right? That you need an approach, you need a scientific approach. Because your logical mind, until the point it has been calmed down or given some answer to a certain extent, it won't even let you meditate, you know? So you need to feed your logical mind first of all.
Hmm.
But then that logical mind has to be dropped at some point, because you cannot go into meditation if you keep holding on to that. And
Hmm.
the example that he uses is so beautiful. He says that, when you are in a car and you're entering your home, you want to go into your room, but you have to park your car in the garage, right? You can't say that I can, I'll just keep sitting in my car, and my car should take me to the room. No, you have to get out of the car and go to your room, and then just totally relax, right? It's exactly the same. So the logic will drive you very close, very, 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 very close to what the reality is, to what the the consciousness is. But at that time, and you come to that point with your scientific temper, with the logic, because again, you will doubt something with your logic mind, and you'll be like, sure, I'll go ahead with this doubt, and you'll try to, find answers, and you'll do your work on that step by step, step by step. And once you're at that certain point, that time you have to let go of your logic, because
Hmm.
it is also, this statement was very revolutionary for me. When I was stuck in my mind all the time, I think it was in one of the talks only Gurudev said that this mind is also a part of the nature. It was given to me, to us, when we were born, when we came into this, came as a being, right? So, and this will dissolve, it will go back when I die. So, nature is the bigger picture, and mind is a part of it. So, I cannot keep this as like the ultimate thing.
Hmm.
So, this was a big eye opener for me.
Yeah, again to the car analogy, you can go till the house with the logic, but to step inside, you need what do you need? Faith.
You need faith. Yes.
Okay, that's a very interesting point. How would you give a scientific definition of meditation?
Wow. Scientific definition of meditation. Hmm. I would say scientists love to experiment, right? They should just experiment with meditation as well. Until and unless they experiment, they will not understand what the result is or what
Hmm.
is behind the curtain. So they should experiment with this also,
Hmm.
and not just hold on to that tightness in them that I cannot meditate or this is not for me. Take that scientific temper, that approach in this also, and say that, okay, I'll give it a try. I will experiment and see for myself.
What are your thoughts on Big Bang Theory, the TV show?
The TV show, it's a fun show, but I think some things are very cliche and, very, um how can I say it? Like they're shown in a very typical manner, like some of the lady scientists or that Indian guy who is very shy and all that. But I mean, that apart, of course, they're making a show, so that they have to put all that. So we should just take that at in a very light note. So that's for
So,
fun.
what is the right? Do they use actual scientific thoughts and then make a humor out of it? What do you think about the scientific terminologies and things they use?
Yeah, yeah,
Do
that
you
is
do
all.
scientists like watching the Big Bang Theory?
It's a good show. Yeah, I think especially the theoretical physicists can appreciate that much more than experimental physicists, because they use very some typical jargon of their theoretical physics. But yeah, they're using the right terms, and I think they're all these dialogues and all those specific, they were written by some physics professor. I don't know if from MIT or someone, but they were written by a professor, so they use the exact terms. Maybe I should ask this. Some of my colleagues are in MIT, and other than being a PhD candidate, I am also a facilitator of equity, diversity, and inclusion workshops and sessions for the American Physical Society. So I'll give you a little idea about what that is. So there is a group of physicists that are in America. So that is called American Physical Society, and there is a similar one in Canada also, that is called Canadian Association of Physicists. So I am a member of both of those these societies. So as a part of my PhD journey, a lot was happening on the so at my lab there are, say, roughly about 1,000 employees. So I am one of the maybe two or three Indians that are there. So it's a bit of an international community. So that way, I really wanted to do some work for the underrepresented groups also. So that made me become a founder of such a society at Triumph itself. And then when I went beyond that, and I started facilitating these workshops for American Physical Society also. So some of the universities that are my the professors and research scientists who participate in my facility, in my sessions, they are from MIT and all some of these Ivy League universities. So it's quite interesting.
What are some tips you would give to students who are pursuing academia as their career?
Tips. um, I would give them both in terms of academia as well as personal growth. First of all, I would tell people that for personal things, to expand their horizon, in the sense that sometimes we just get stuck into our own little world. So we're not open to um, reaching out to other people and talking to others, which nowadays is also becoming more and more prevalent because of all the social media and everything. People are so into themselves, and they don't like to live talk with people.
So you're giving a tip to them to give a live talk.
Live talk in
Connect.
the sense connect on a the three-dimensional space, not in the two-dimensional Zoom space, or just
Physically meet
being
the academics,
physically
and
meet
so
and
this is.
talk and reach out to people. For example, you want to know about what can be the options, you want to explore them, write an email to a professor or people who are in academia.
So where are
Go
these
and meet
professors
them.
found? We find business people on LinkedIn. Where are the professors of academia found?
They are, oh, so you would, when you go to the websites of the universities, you can find their email ID and short bio. They've written about their what research they are doing, and also sometimes they've mentioned about the open positions if someone is interested in their research. So you just send them an email.
So basically, search by the topic of your interest, find the universities there,
Yeah,
connect with the professors which
yeah.
have LinkedIn. And I guess both most of them are active with the emails.
Yeah, this is how when I was looking for my PhD uh, groups, like the topic in which I was interested in. This is exactly what I did. I used to go explore all the university websites. It takes a lot of work, a lot of work, and then you just filter out that, okay, then you read through that, okay, this team is doing this work, then you start sending. Your job is to send them an email, but don't just like write like a rubbish email that, okay, hey, I'm interested, can you tell me more? No, they get thousands of such emails on a daily basis. Be like a write an authentic and a genuine, not a chat GPT prepared email also. So and very nicely draft your email with what you have done, what is your experience, what you're looking for, with your CV and everything. So then there are more chances that they will really take that seriously.
Okay. All right. So it was great talking to you today. Any concluding thoughts or remarks for the audience?
Concluding thoughts. I think that I have another tip for not only students but youngsters like you and I, who have really swayed away from the world of spirituality, from the world, the beautiful space that lives within us. So I don't have any problem with people, doing social media or whatever, rather than I should phrase it in a better way, that there is no problem, not that I have a problem, there is no problem in you being, very much involved in social media, this and that, being active and everything in your personal and professional lives. But at the same time, I would say that, cater to to your soul as well, because it needs food also, and the food for the soul is meditation and taking a step back and going towards that inner journey, which is a very individualistic journey. So try to connect, try to learn more about, about maybe your own religion to begin with, and then slowly step into the, sometimes spirituality can be stepping into an unknown territory, which could be a bit overwhelming, but you just start from wherever you are. But try to appreciate that aspect of yourself as well. Invest some time and energy into yourself and stay connected with both the scientific temper in yourself and also the spirituality part of it, which will be very nourishing to you and your journey.
Okay. Thanks a lot.
Thank you, Tanmay.
Thank you for watching this podcast till the end. Please let us know in the comments what more topics and guests would you like to see in future episodes.